Introduction to Neural Networks with C#, Class 10, Part 3. Welcome to Class 10, Part 3. In this part, we're going to see how to predict the sine wave. Now, the sine wave is completely predictable, so why do you need a neural network to predict it? Well, we're going to move on to more complex things like predicting or attempting to predict the S&P 500 in Class 11, but for now we need to see the foundation of how to predict with a neural network. We also need to validate that the software that we write to do this will actually perform on something that we know what the outcome is going to be. We will see both how to train the neural network for the sine wave and also how to validate it. We will begin by looking at how we set up the neural network for the sine wave. Here you see the sine wave. This is what we're going to predict. This is only a small section of the sine wave. The sine wave actually extends from negative infinity to positive infinity in the x direction. In the y direction, it has a much smaller interval, and we can expand it beyond this by multiplying it by a coefficient. However, this is the sine wave multiplied by the coefficient 1. We are going to feed the data from the y range into the predictive neural network so that we can predict this. This is, of course, completely predictive, but we are going to use it as the foundation to predict much more complex things. You will also notice that the range that we are trying to predict extends between both positive and negative numbers. This means that we must use the hyperbolic tangent as an activation function rather than sigmoidal, because that accepts both a positive and a negative number range. We need to consider how we're going to construct the training data for the sine wave prediction. We're going to use an input count of 10 and an output count of 1. That means that we are going to break the sine wave into 5 increment intervals, and we're going to predict one interval past that. So we need to feed in 5 previous data points, and it will predict one data point into the future. Each of these data points for the first 5 and the output are going to be exactly 10 degrees. So we're basically breaking the sine wave into 10-degree intervals, and we will use each of these 10-degree intervals to predict the future intervals. So since we have 5 inputs, we are going to basically use 50-degree range to predict one interval for the output, which would be 10 degrees. So 50 degrees to predict 10 degrees. And here we see what the data looks like when it is actually produced. You see the inputs ranging from the first 5 columns, and the output is the rightmost column, the 6th column. This is the data that we will actually use to train the neural networks. These are actual values that were produced by using the actual data generators that we saw in the previous section to generate actual training data for the neural network. We will also use this data to validate the neural network to see how close it is coming to actually predicting real output from the sine wave. This will be done after the training is done. We will use some of the data that we did not use for training for prediction to validate the neural network. This will allow us to see how well the network is actually performing with real sine wave data after the training has completed. And here we see the progress of the training. We take it through a total of just short of 5,000 iterations. You can see the first 5 iterations where training begins. Training does not begin particularly well. We're at about 48% error. Training continues, and the error rate drops considerably. By the time we have reached the 4,995th training iteration, we are at around 2%, or actually 2.3% error. This continues until we reach the 4,999th interval, and then we are done with the actual training. At this point, we have a reasonably low error rate of around 2.3%, and we are ready to actually validate the neural network. We will present it with real data, and we will see how well it actually performs against it. And here we see the validation stage. There's a lot of numbers. We can see the actual values and the predicted values, as well as the difference between those over various degree ranges, the 5th, 6th, 7th, and so on. Some of these are the data elements that it was trained on. Others are new data elements beyond the range of which it was trained. It tends to perform relatively well on all of these. You can see that the difference is usually less than 4%, sometimes well less than a single percentage point. You're only seeing a small subset of the items that was verified on, but the other ones tend to perform about in this range. So it predicts within a reasonable degree of accuracy. We could have had greater accuracy for training it longer. However, 5,000 iterations was enough for this small sample.
This concludes Class 10. In this class session, you learned how to predict with neural networks. Unfortunately, we only learned how to predict the sine wave, which is not terribly interesting. In Class 11, we will take what we learned in this class and apply it to the financial markets, and we will see how neural networks can attempt to predict patterns in more complex temporal series, such as financial networks. We hope you will continue with Class Session 11. Thank you. This course is based on our Introduction to Neural Network Programming books for Java and also Introduction to Neural Networks for C#. Available in both paperback and ebook format.